My name is Jim Kibbe. I'm the Regional Sales Manager for Lakos. Been with Lakos for 12 years. And today we're going to have a webinar. We're going to jump in the life of Maintenance and Operations Group and try to see how we can help them beat some cost savings goals with utilizing our premium efficiency filtration equipment. So let's get started. Regardless of what type of HVAC system you have, it could be small, it could be very large. Most of the components stay the same. In the top left, you see a small package tower. In the top right, we have a large field-erected tower. This might be used for a central energy plant. But again, regardless of whether it's a large HVAC system or small, most of the components stay the same. You're going to have some chillers and also potentially some plate heat exchangers. The agenda for today, again, I told you we're going to jump into the life of the Maintenance and Operations Group, uncover some of the common problems they have with their cooling water system. We'll also talk about some traditional filtration options that you can use to combat these problems. We'll discuss separators versus other technologies, primarily barrier technologies. And then we'll finish up talking about the benefits and features of our new premium efficiency filtration system and where and how you can use it. So for the life of the Maintenance and Operations Group, they've got a big job on their hands. They inherit a system that's supposed to have a certain duty for heating or cooling. And the number one expectation is to maintain that equipment so that it works 365 days a year, the same day it did the first day, as it was brand new. And so they have several common goals. They have to maintain their equipment. They have to do preventative maintenance to keep it up. They have to try to reduce their forced outages or any unscheduled downtime, or possibly eliminate that. They have to do this while meeting a budget as well. So they have to stay within their budget means. And at the same time, they have to maintain a safe work environment for their workers. So in order to do that, they're challenged with many different types of strategies. They have forecasting, they have scheduling, then you have planning, then you have to implement it. You have daily fires to put out, you have durability that you need, and all at the same time, you want to make sure that the system's maintainable, that you can maintain it like you did the day you took over the equipment when it was new. So with that being said, Zach, if you could please start the video for maintaining hydronic system efficiency with continuous filtration.
In a typical 200-ton cooling tower that operates at 1,000 hours a year, you could see as much as 600 pounds of particulate in the cooling tower. So ASHRAE recognized at that point that yes, that dirt getting into the system through the cooling tower can be a major issue in how the entire system operates and the efficiency of that system.
Depending on the location of the cooling towers, there's airborne dirt typically in any spot throughout the country or the world for that matter. As the air brings that material, whether it's dust from agricultural processes, construction environments, concrete sites, brake dust, tire rubber, all that material eventually becomes airborne, and in that it can cross the cooling tower surfaces, and as the air is drawn through, the water will scrub that material down into the basin. The main problems that dirt creates is under deposit corrosion in your basin. It's a labor-intensive process to remove dirt manually. You have inefficiencies of your heat exchangers, whether they're shell and tube or plate and frame. And overall, your mechanical system cannot operate at its best efficiencies when dirt interferes with the overall process of maintaining temperatures.
As dirt builds up inside the cooling basin, it's going to provide a breeding ground for bacteria, which will decrease the efficiency of the algicides and or biocides that the water treatment company is using inside the hydronic system.
We're attacking the particulates where they come into the tower, where we see the most buildup before it gets downstream to the system and can affect the heat exchanging properties of the downstream system.
As an engineer, you should be concerned with both water treatment and mechanical filtration. It takes both water treatment and filtration to work together to have a clean hydronic system that operates efficiently and as designed.
talking about ASHRAE and how ASHRAE knows that there is dirt in the system and that it is going to cause a problem. They recognize that using mechanical filtration as a means to combat particles from entering the system is a good idea. But basically, ASHRAE was saying a lot of the particles will enter through the cooling tower and also the makeup water. And as that happens, dirt's going to settle, and the components in which it's going to settle are shown here on the screen. Most of them start in the cooling tower basin. This is also known as the cold water basin. However, most of the particles do not just stay there. They'll travel throughout the system. They'll visit the condenser tubes. Here we have a condenser tube with special surface area, or more surface area, enhanced tube. But what happens is when the flow downturns, or if you have low flow, or it becomes laminar, a lot of particles will settle out inside the condenser tube and create a scale formation. We also have some plates here, plate heat exchangers. If you have them in your system, they're prone to fouling as well. And the bottom right here, we can see that there was a lot of scale buildup in mud or muck inside the system. And also here inside this port for the plate heat exchanger, it's almost plugged entirely. So the maintenance group's going to have to get together, take this apart, clean it, probably regasket it, and then place it back in service. If the dirt does not settle in the cooling tower, the condenser tubes, or in your heat exchanger, if it's lucky enough to find its way back, it's going to go actually back to the cooling tower into the hot well of the basin, and it's going to potentially plug up some of the fill. There's a lot of dirt in there. So in the video, it talks about, or ASHRAE talks about, we're going to have solids. Mechanical filtration is a great way to try to combat that. You saw where the dirt settles out. Well, now we want to figure out what the dirt is going to cost us of having it in our system. So in 2011, AHRI, the American Heating Refrigeration Institute, came out with this chart, and it's great because it shows you what happens when you have scale buildup versus the energy consumption inside your condenser. I note there's 3 columns here. The first one is fouling factors. The second one is scale thickness on the inside of your condenser tubes. The third one is the percentage of increase in energy consumption that you're going to see based on the scale formation. So if we come over here at 0.001, that would correlate that we have 12 thousandths of an inch of scale on the inside of the tube. And if that's the case, then the condenser will have to use 11% more energy. Now note this is linear. So for every thousandth in fouling, if we go to 0.002, we would move up from 12 thousandths of an inch scale to 24 thousandths of an inch of scale. And that means the condenser is going to have to use 22% more energy. Well, this is huge. In a hydronic system, just say your chiller cost is going to be $200,000 a year. If you're fouling at a rate 24 thousandths of an inch of scale, you're going to have to spend over $20,000 in extra energy cost. So there's a huge impact in energy and energy consumption when you have a lot of particulates inside your hydronic system. And remember, for every 12 thousandths of increase in scale thickness, the energy consumption goes up by 11%. We just talked about the energy problems, but here are all the common problems that are caused by particles in the cooling water system, and it just gives the maintenance and operation guys a nightmare. We just talked about inefficient heat transfer. It's going to create reduced temperature approach in the chiller. We talked about that. Your energy costs go up. If you have dirty cooling tower fill, it increases your energy consumption. When you have accumulation of solids in the basin, it's going to increase your maintenance cost as people have to go in to clean it. If you have plugged condenser tubes, it's going to force an outage or unscheduled downtime where you'll have to punch chiller tubes. And then again, with the solids accumulation, you're going to have sulfate-reducing bacteria, and when that occurs, it's going to increase your chemical usage inside your hydronic system. So these are all the problems. There's a big increase in maintenance costs, downtime, and wasted energy. So ASHRAE told us we're going to have problems with particulates, that filtration is a good way to combat it. Well, there's a couple different traditional types of filtration. And here on this page, we have barrier filters. On the next slide, we'll have non-barrier. But everything on this page has one thing in common, that they utilize some type of medium to capture and remove particles from the hydronic system. And as they do build up particles on the medium, whether it's a filter cartridge, a screen, a sand bed, a bag filter, or disc filter, the differential pressure will rise up, and the flow downstream is going to go down a little bit until you either change the filter or you activate a purge or auto clean method, which could be a self-cleaning screen or the purge for a disc filter, or a backwash on the sand filtration system. But keep in mind there are some limitations here. There is constant maintenance if you're using filters. If you're using sand filters or disc or screen filters, you will be losing some chemically treated water through the purge or backwash process. And if you're using a sand filter, every so often you're going to have to address the media and replace the sand in it. There are limited applications for all these technologies. The non-barrier filter that we're going to talk about is the separator for Lakos. It's the flagship for Lakos. And we don't rely on a barrier to move any particulates. We rely on centrifugal action created inside the separator. So there's no moving parts. There is no maintenance. There's no downstream loss of flow due to buildup of differential pressure. Although the solid loading may increase inside a separator, the differential pressure does not. The flow always stays steady to the heat exchanger or the process. And so you have a continuous runtime without any maintenance or interruption. And if you so choose, we can set up the system so that you have zero liquid loss, like you would want in a chilled water loop. The three different types of technologies that Lakos uses a lot when we're dealing with a hydronic system, a dirty hydronic system. And here we have a barrier and non-barrier. We'll talk about the differences because there's benefits of both. The particle size for a Lakos separator, which is a non-barrier. We can remove particles 45 microns and larger. In a recirculating system, we can get down to 25, with some other options down to 10. The barrier filters are sized. The self-cleaning screens, you choose a screen size. It could filter anywhere from 5 to 500 microns. And then the sand filter media, they're going to filter everything 5 microns and larger. The particle types are going to be a little bit different too. The Lakos separators are primarily taking out inorganic particles, the sand, the silt, the scale, calcium carbonate, rust, that have a specific gravity of 2.6 or greater, while the barrier filters can take out both organic and inorganic particles, both of them, the sand and the self-cleaning screen. And this is where there's a big differentiation right here is the volume of particles. The Lakos separator can handle a tremendous amount of solids loading. You can handle up to 0.5% of particles by volume. That's 5,000 parts per million. Whereas the barrier filters can't handle nearly the dirt load, where the light polishing type filter, the self-cleaning screen, it has a maximum of 100 parts per million. So you're already dealing with pretty clean water there. And the sand filter really can't handle more than 200 ppm of solids. So the separator really shines in this application. The flow rates for the separator can go all the way up to 12,700 gallons a minute. We can go up to 7,300 with the self-cleaning screens and up to 1,000 in the sand media filters. And then just in the notes in the bottom, the separator is using centrifugal action, whereas in the barrier filters, the self-cleaning screen is using a suction scanner to remove the particles off the screen surface. And then the sand filtration is using a media bed of sand and an underdrain to remove the particles. A note, all three of these systems can be highly automated, where you could utilize them for very different applications. In fact, if we could, Zach, we have a basin sweeping video here. If you could turn on that. Okay, well, you saw how well the basin sweeping system worked. I really, really, really like this method of filtration because it takes care of the problem at the source, which is the cooling tower. And we found out over the years, if we can keep the cooling tower clean, we can maintain the entire hydronic system and keep it clean as well. Again, it's also going to eliminate downtime and maintenance in cleaning the towers. It also allows the water treatment guys to use corrosion inhibitors to protect their basin, also algicides and biocides to keep the system clean as well. I find this to be the best fit overall. And again, you could use them with sweeper systems with centrifugal separators. You could use them with sand filters. You could potentially even use them with self-cleaning screens. In some cases, you might not be able to use a basin sweeping system for whatever reason, the time of the year, or you can't shut down, but you realize you need to have some type of filtration and you want to keep your scheduled outages, on an annual basis. Well, then we might look at a side stream system to help us out there. So maybe you can't drain the cooling tower and get somebody in there, but maybe when the system's down over the weekend, you could hot tap the condenser water line so that you could do anywhere from 10 to 25% side stream filtration. I try to stick with a higher percentage, 25%, because we can only see the particulates that come in contact with the separator. So the more filtration we can do, the more help we can provide the condenser with taking the dirt load off of it. It's easy to retrofit. You can have these in the mechanical room inside, or they could be outside. And the only thing it doesn't do is it doesn't address the basin. You'll still have solids build up inside the basin, and that's where a lot of the problems start. But it might can help you extend your outages or keep you from having a forced outage where you can meet your scheduled outage at the end of the year. And then we have full stream cleaning. This is simple. This is where you're filtering 100% of all the water leaving the towers going to your process. You could also use it as point of use filtration. You might have a water source heat pump somewhere that's plugging up. You might have a plate and frame heat exchanger that gives you issues. Well, you can put a separator directly in line in front of it to protect it from fouling without reducing any flow to the heat exchanger or affecting its heat load or duty. And again, these can be installed inside, outside as well. Well, we talked about dirt getting in the system, maintaining the system, some mechanical types of filtration. There's a couple different ways you could do it, but I really like the Lakos Premium Efficiency System. We came out with this a few years ago. It really removes all the dirt and the debris from the water. It's easy to retrofit. You can install it in the field. It's keeping your towers, your condenser tubes, and your heat exchangers clean. There's two pictures in the bottom here. I'll show you. On the left-hand side, we've got a system set up, and we've got an alternating valve switching kit so that we can switch back and forth between the two towers. And you can change the duration of filtration along with the frequency as well. On the right, we have a standalone unit that is designed just this one tower. But also note that if you have multiple towers or multiple cells, as long as there is an equalization line between the towers or cells, you could have one unit do multiple towers. Don't let that deter you. You don't have to have a filtration system for every single tower. We can utilize equalization lines. And again, we also have multi-tower switching kits. Another nice thing I like about the Premium Efficiency Separator is that we can actually get down to 25 microns. And we did this with third-party testing. It is the only product with independent testing as far as centrifugal separators go. The nice thing about this is we also can package it several ways to customize it. We could use closed couple in suction pumps. If you have a remote sump with a deep water level and you can't use a centrifugal pump, we have self-priming pumps. We have vertical turbine pumps. And we can also customize the unit. If you want to set it up for zero liquid loss, we can do so, or no maintenance, we can do that as well. And just to give you an idea of how fine 25 micron is, we have a chart just below here that shows you 44 microns, 37, and down to 25. 25 microns is the same size as the white blood cell. That is very, 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 very fine filtration. Just so you know, the human eye can only see down to about 40 microns. So we're taking out particles below what the human eye can see. And again, if you're going to be purchasing a tower, or if you're an end user and you want to buy a tower, if you're specifying it, try to specify it with third-party independent testing. If you want to see how the testing took place, go to our EHTX brochure, and on the last page, it'll tell you how the International Center for Water Technology, located in Fresno, California, how they set up our test, how the test was administered, and then the performance results from the test. And again, we have it for all of our EHTX separators, so I encourage you to go check that out. And finally, a couple takeaways. We know, because ASHRAE says that particles cause problems. We know the AHR put out a chart that shows how much energy consumption goes up from fouling. We talked about filtration methods to remove those particles. We can provide a tremendous energy savings, reduce your maintenance, and maintain your design efficiencies as of the very first day you took advantage of that equipment or you took ownership of that equipment. We can make it run and keep it running like new. Lakos systems, like I said, a lot of times are sold into the plan and spec market when people are picking chillers and heat exchangers. They can size a filtration system then, but if you happen to take over a system and it wasn't installed from the factory, they can easily be retrofitted on site. And the other takeaway is take advantage of the premium efficiency system that Lakos has come up with the filtration down to 25 micron of recirculated systems. Help out your maintenance and operation group maintain their equipment as it was designed. And with that, I'll say thank you. We're going to open up for a couple questions and answers. Okay, we have a question here. It says, what is the best way to express the way these systems work in conjunction with chemical treatment? That's a good question. Every filtration system, you need to have both water treatment and filtration, and the reason that is because Lakos takes out all the particles that foul, like sand, silt, scale, the inorganic, or the inorganic thing, the calcium carbonate and silica, where water treatment handles the biofilms. It's going to be bacteria, algae, mussels, things of that growth. Lakos can't control that, so we need water treatment there to control biofilms, because you can have fouling inside your chiller with a biofilm, and it could be just as bad as if it were fouled up with scale. So that's a good question. It takes a 1-2 punch. You need both a good water treatment program and a good filtration system. Is this, I see one that says, I don't like to use water treatment hooked up to Lakos. If the Lakos fails, water treatment fails. Yeah, it's not set up for that. Some water treatment people try to do that. We try to get away from it. Sometimes they try to take over our controls and set our purge to blow down the tower. It's not designed to do that. It's designed just to purge the solids that are in the separator. So if you're gonna, you can do it. We just don't recommend it. And you need to be savvy if you're a water treatment guy or a chemical guy. You need to have your own system set up for that. We should be independent of the water treatment system. See another question that says, in our region, many of the water treaters utilize a purge valve on the separator for conductivity control. Any thoughts on that? As I just mentioned, some people try to do that. You can do that if you're pretty savvy, but we really don't recommend it. There's already blowdown controls on the tower. We should recommend just using those, unless you're very, very, very experienced. It says, can you address the business case for using a TCX 25 micron particle removal versus a TCI as it relates to the fouling? You touched on corresponding energy use. In other words, how does separating smaller particles correlate to the reduction in fouling and subsequently save energy? It really depends upon the type of particle that you're dealing with. The particles that cause the most fouling are calcium carbonate, and the second that you turn the cooling tower on, you start evaporating water. The minerals don't, and the number one is calcium carbonate. Now, whether it's 25 micron, or whether it's 40 or 50 or 100, what happens is they agglomerate. You get a piece of silica, you get a piece of calcium carbonate, you add water, and it makes that hard scale formation inside the tubes, and it just gets worse and worse and worse and worse. It just really coalesces. It comes together until your tubes are blinded off and you can't meet your temperature approach. You really can't say that it's just this one 25 micron particle size. It's actually, the bigger the particles or the bigger the problem, but if the particles are silica and they're calcium carbonate, that's when they're the most dangerous. You can't really just say it's this 1 micron rating particle. It's the actual contaminants that come together inside the system that create the bigger overall problem. I have another question. If we could share the presentation. Yes, the presentation will be shared on our website, as will all of our webinars. So if you missed some previous ones that Tom Cavasset or Steve Geisel might have done, go to our website, and you should be able to see this video along with all of the others. But again, my name is Jim Kibbe. I appreciate you coming out and listening today. My email address is on the screen. If you have a question or you think of one later, just email me at jim.kibbe@lakos.com. I'll be more than happy to answer any questions that you might have. Again, thanks for your time, and pay attention, as in the future we're going to have a couple more webinars. I think I'm doing one on some configurator training, so if you haven't checked out our configurator, please do so. And again, thanks for coming today.